a special function called a piecewise function, okay? A piecewise function, it has this name because the functions come in pieces, as you will see in just a second, okay? So if you would, please go ahead and copy down your heading at this time. Your heading for today is piecewise functions, and that is a mistake right there. It should just say piecewise functions, alright? Piecewise functions, we're going to get to step functions later in this lesson. In fact, that's why this lesson is called Part 1. I was going to teach this all in one day and I changed my mind, okay? So, piecewise functions, that's your heading, lesson 6.4, Part 1. And always I encourage you guys to put today's date so that you have good organized notes, okay? Alright, let's continue on now. Like I always do, let's start off by getting a good look at what a piecewise function looks like, okay? Here is an example of one. Now, as I'm rambling, please copy this in your notes. We're going to use this after I get done talking about this. We're going to use this for our first example in just a minute. We're going to do a couple things to this piecewise function, okay? So, copy this down, and while you're copying, keep one ear open, okay? First of all, we call this a piecewise function because it comes in pieces, okay? Here's the first piece. Here's the second piece. Now, are these pieces over here? No, they're not, and we'll talk about those in a second, okay? Now, is it possible for a piecewise function to have more than two pieces? Most definitely, okay? The main thought behind a piecewise function is simply it has different pieces to it, okay? So, this piecewise function here has two. I think most of the ones we're going to work with have two, okay? Now, step functions, which we'll get into later, in probably the next video we do, those have more than just a couple pieces, but right now we're talking about this function here. There's two pieces to it, okay? Now, f of x equals, then we have a bracket, so here's what it's really saying. Now you can take notes on this or watch. It's really saying f of x equals 2 minus 1. And also f of x equals x squared minus 2x plus 1. Do you see what I'm saying? So in other words, men and ladies, we have two different equations. So if we were to graph this, we have two different pieces to graph. Okay? So, now what are these here? Well, these are domains, if you want to make note of that in your notes. They are domains. Or we also call them constraints. Either one of those would be accepted mathematical terms to use. Okay? Now, notice the constraint for this function is x is less than or equal to 1. Notice the constraint for this function here is x is greater than 0. Now, or excuse me, x is greater than 1. Now, what that means is the only values you can put in for x are values less than or equal to 1. The only values for this function that you can put in for x are values greater than 1. Okay? So, we have different pieces to the piecewise function, and each piece has a constraint or a domain that goes with it. Okay? So that's a little explanation of what a piecewise function is. Now, I'm going to move on, so all of this is going to disappear. So, like that. So if you want to copy any more stuff down, pause the video and do so. I'm going to go ahead and move on. Now, we are going to learn to do two things today with piecewise functions. We are going to learn how to evaluate them at a given value, and we are going to learn how to graph them. Okay? So that's what we're going to do today. Evaluate a function and graph a function. Alright? So, let's get the journey started with, I'm sure, a lot of excitement. Here we go. Let's go ahead and use this function that you have already written in your notes, okay? So in your notes, you should already have this function written down. I want us to evaluate it at 5 different values, okay? First of all, so please write this down. First of all, we're going to evaluate this piecewise function at f of negative 2. That means we're putting negative 2 in for x. So your first thought probably is, Mr. Earhart, we're going to have two answers. We're going to put negative 2 in for x here and get out an slow down. Remember, you have constraints right here. So these constraints tell you what you are allowed and not allowed to substitute in for x for this function and for this function. Don't forget that, okay? So, with that in mind, actually we're going to get out one answer because I'm going to evaluate this function right here at f of negative 2. Well, I'm not allowed to put f of negative 2 into this equation because look, all of my x values have to be what? Greater than 1. So I'm going to use this function, 2x minus 1, because this function is all values less than or equal to 1 and negative 2. The number I'm putting in for x is less than or equal to 1. So 2 parentheses negative 2, negative 1, negative 5. So f of 2 equals negative 5. Or in other words, you have an ordered pair, negative 2, negative 5. Got it? Really simple, guys. Really it is. Alright, let's try the next one. F of 0. Now you've got to decide which constraint does f of 0 fall into. Does it fall into this one? X is less than 1. Is my x value 0 less than 1? Yes, it is. Does it fall into this constraint? No, it does not. By the way, let's stop. I can read some of your minds right now, Mr. Error. What if one of the values fell into both constraints? Then you would have to evaluate both and get out two different answers. Okay, that can happen sometimes. Actually, it hardly ever happens. In fact, I'd be surprised if it happens at all. But if that were the case, that is what you would do. Now, obviously, 0 does not fall in this constraint. This says all numbers greater than 1. So we're going to use this function right here. And we're going to substitute 0 in for x. 2 times 0 is 0 minus 1 is negative 1. So f of 0 equals negative 1. Or you could say 0, comma, negative 1. You put in 0, you got out negative 1. You put in negative 2, you got out negative 5. Now let's go on to the next one. Now we're dealing with f of 1. So I'm putting 1 in for x. Well, guys, notice this little equal sign right here. This constraint here says all values less than and equal to 1. So 1 definitely fits in this constraint. 1 does not fit into this constraint because this constraint says all numbers greater than 1 and 1 is not greater than 1. So we're going to use this function again. Where the x is, I will substitute 1. 2 times 1 is 2. 2 minus 1 is 1. So f of 1 equals 1. Or you could also say 1 comma 1. Alright, now let's continue on. F of 3. 3 does not fall into this constraint. This says all values less than 1. But it does fall into this constraint. All values greater than 1. And 3 is greater than 1. So we're going to use this function right here. So everywhere there's an x, we're going to put a 3. I would always use parentheses, students, if I were you, when it comes to making substitutions for variables. 3 times 3 is 9. Negative 2 times 3 is negative 6. Bring down your positive 1. If you simplify, you'll get 4. So f of 3 equals 4. Or you could just say 3 comma 4 would be acceptable. Alright? Okay, let's move on. Aren't these simple, guys? I hope you find this simple. I mean, look. All that you have to do is decide which function to use. And how you decide that is whether or not the value you're substituting in, this value right here, fits into which constraint. For example, we're going to substitute 7 in for x. Well, there's no way 7 fits in this constraint. This constraint says all numbers less than or equal to 1. However, this constraint here says all numbers greater than 1 and 7 is greater than 1. So we're going to substitute 7 in to this function right here. It'll be a little tight. We'll try to squeeze it in here. X squared minus 2x plus 1. So parentheses 7 squared minus 2 parentheses 7 positive 1. 7 times 7 is 49. Negative 2 times 7, negative 14, positive 1. And if you combine those, you should get 36. So f of 7 equals 36, or you could say 7 comma 36. You put 7 into this function and you got out 36. So I hope that you're understanding this. Evaluating is the easiest part of what we're going to do. Graphing is where it gets a little challenging. I'm not going to lie to you, okay? That's where it gets a little difficult, alright? But the main thing you got to realize is, and where students get confused on evaluating, is making sure they put the number into the right function in the piecewise function, okay? Alright, moving on. Now, let's go ahead and use the same function and let's learn how to graph a piecewise function, okay? So the first thing you do when you're graphing piecewise functions is you break it up into pieces, alright? That's simple enough, isn't it? That way you can actually see the functions you're dealing with. Alright, easy enough. Now next, you want to write down all the information you know about this function. Let's start with this one. And now you're seeing, students, why I've told you over and over and over. Earlier when the year started, you must be able to identify types of graphs based on the equation. That's why I gave you an exam with different functions mixed all together and told you to graph them. And I gave you a review sheet like that. Or not a review sheet, but we spent days reviewing from the semester because I want you to understand that you have to know this stuff, okay? So, f of x, if it helps you to graph it, if you want to put a y here real quick, there's no problem with that. Just remember it is a function written in function notation, that's fine. Notice your highest power of your variable is a 1. And so this is a linear graph. So we know right away this is a linear graph. When I graph it, I will get a line. Okay? Now, so do you understand what I've done so far? I wrote the piece down. Now I'm writing down stuff about it. Next, I realized that my constraint says all values less than or equal to 1. So I'm going to make a table of values. And the values I put in for x, I'm going to put about 4 or 5 values in. Will be sufficient. And that's up to you. However many you use is fine. Actually, to be honest with you, let me correct myself here. If we know it's linear, 3 points is sufficient. Okay, it really is. You guys are big, older students. You can understand that. If it's a linear equation, we know 3 is plenty. So the numbers I'm going to put in my table of values are numbers that are less than or equal to 1. Do you see that? Less than or equal to 1. So always start with this number. Did you get that? I'm going to get a drink of water while you write that down, or think about that. Always start with this number in your table of values, always. So put a 1. Then next, x is less than 1, so we'll put a what? A 0, and then what are we going to put? -1. Got it? So this right here told me what values to put in for x over here. Okay? Now, let's go ahead and do it. We can do it in our head, guys. This is so easy. Put a 1 in for x right here. 2 times 1 is 2 minus 1 is 1. Put a 0 in for x. 2 times 0 is 0. 0 minus 1 is -1. Put a -1 in for x. 2 times -1 is -2. A -2 and a -1 is -3. So as I like to say, booyah, done. Now, let's come over to this. We'll graph this in a second. Now, let's come over here. Now, let's write down everything we know about this. First of all, if you want to write it with the y, if that helps you, fine. You don't have to. It's totally up to you. Nothing wrong with that if it helps you. The first thing you should notice is we have a quadratic equation. Do you understand that? We have a quadratic equation. We know that because I have a power of 2 for my exponent. That's the highest power that I have. Okay? So you should know if we graph a quadratic, what do we get, guys? Come on. You guys know this. That's not right. Parabolia. That's not right. It's like a disease or something. Parabola. Alright, there we go. So we know we're going to get a parabola if we graph this. But it might be half a parabola. You understand that, don't you? Because we're only going to put certain values in for x, okay? But understand, it's a quadratic function, okay? Now, for linear functions, for a table of values, we usually use how many ordered pairs? 3, okay? But for a quadratic, we usually used how many, do you remember? We'd always have 5, remember? We'd put 5, and we'd put our vertex right here and all of that, okay? Now, we're not going to find the vertex this time because, remember, we have a constraint. And this constraint tells us what our x values are going to be, okay? But we're still going to do a table of values with 5 ordered pairs because it is a quadratic, and quadratics are a little more complex. So I want to get a really good picture of this thing. Does that make sense? All right. Okay, now, here we go. All right, now, I know what you're thinking, Mr. Earhart. Its value is greater than 1, so I'm going to start with 2. No. Remember what I said earlier? Always start with this number. Always. Or Mr. Earhart, you're not allowed to because it's not equal. I know that, but watch what I'm going to do. I'm going to put a 1 here, and I'm going to circle it. Now that reminds me that when I plot this point, there's a hole there in the graph, an empty space. And there's an empty space there because, listen, you're not supposed to put 1 in. But I'm breaking the rules. I'm doing it anyways. Okay, you're supposed to because you want the graph to go right up to 1, but not quite get to 1. So we're going to put 1 in and we're going to circle it. Now, do you understand why I did not circle this one? Because this value of 1 right here was allowed. It was equal to 1. X is less than or equal to 1. So because it's equal to it, I'm allowed to put 1 in here. So there's no need to circle it. Over here, I'm not supposed to put 1 in. X is greater than 1. So I'm going to go ahead and do it anyways and circle it to remind me what did I actually... I did, didn't I? That's embarrassing. Alright. That's actually very funny. Okay. I do know how to spell. Wow, that's really funny. Don't tell Miss Yukonen. Alright. So we're going to have a hole in the graph. Okay. Now, let's continue on. The constraint now tells us to go greater than 1. So I put a 1. So if I'm going to go greater than 1, I'm going to put what then? 2, 3, 4, and 5. Got it? Okay. Here we go. Let's put 1 in for x. 1 squared, negative 2 times 1 plus 1. 1 times 1 is 1. Negative 2 times 1, negative 2 plus 1. We get 0. Alright, very good. Now, let's go ahead and put what in for x next? 2. And I should have used the eraser on that, shouldn't have I? Been a lot faster. Now, let's go ahead and substitute 2 in for x. So, 2 squared, negative 2, 2, positive 1. 2 squared is 4. Negative 2 times 2, negative 4, positive 1. So you get out a 1. Alright, fair enough. Let's move on now to the next value for x, which is 3. So substitute 3 in for x. And here we go. 3 times 3 is 9. Negative 2 times 3 is negative 6, positive 1. And you will get out a 4. Alright. So there we go, getting out a 4 and moving on. Alright, next we're going to substitute 4 in for x. So 4 squared, negative 2 times 4, positive 1. 4 times 4 is 16. Negative 2 times 4, negative 8, positive 1. And that would be 9. So we get out a 9. Alright. And then we're going to substitute 5 in for x. And we will get out 5 squared, negative 2 times 5, positive 1, 25, negative 10, positive 1, 15 plus 1, 16. And there we go. Now what I'm probably going to do is get an extra page here and slide this back and forth because we need a lot of room here for this graph. And so here we go. Now, I think because I've got some large values here, well, you know what? I'm just going to go ahead and extend the y to 16. So that's what I'm going to do. So let's shrink it down a little bit, slide this down a little bit, and let's see if we can do this. Let's extend this thing up to 16, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and we are good to go. Alright, let's grab this part of the function first, okay? Here we go. 1, 1, 0, negative 1. So 1, 1. 0, -1, and -1, -3. Now, after you put those 3 points, what are you guys used to doing? You're used to just going like this and drawing your line, right? Absolutely not. Why, Mr. Earhart? Well, thanks for asking. I'm glad you asked. Because students, dudes, we've got constraints. Look, we've got a constraint. So the line doesn't continue going in both directions. Here's what I always teach my students to do. If you've set up your table of values correctly, always put your pen on your first ordered pair right here, 1, 1, and then draw from there. So here's what we're going to do. We're going to put our point, our pencil, on 1, 1. 1, 1, 1, 1, 1, 1. There we go. Okay. There's 1, 1. Now why 1, 1? Because that's the first point in my table of values. Okay. So I put my pencil there and I draw going toward the other points like this. There you go. That's it. We did it. So now you know where to always start. Start at the first ordered pair, working your way away from that ordered pair. So same thing with these ordered pairs now. So 1, 0, and 2, 1. So 1, 0. Now don't put a point there. Don't put a point there. Remember, it's supposed to be a hole in the graph. Remember. So we have 1, 1, and 2, 1. So not 1, 1, sorry. 1, 0, 2, 1. So 1, 0 is here. You put a hole in the graph. Put a hole there. And then over 2, up 1. Alright. And then we have 3, 4, and 4, 9. So over 3, up 4. And then we have 4, and way up to 9. And then we have 5, way up to 16. So 5, way up here. Right there. Now, do you start your pen here and come down and go through this thing and keep going like that? Or do you start here? Well, what did I teach you? Look at your table of values. What is your first ordered pair? 1, 0. So you put your pencil on 1, 0 and you work yourself away. And see how it's kind of like half of a parabola? Do you see how it's kind of curved here at the bottom and then it goes up? And that kind of gives you some reassurance that you have the right graph. If you graph the whole parabola, it would probably look something like that, okay? So that's it, guys. I mean, I'm not the best teacher in the world, but I really can't make it any easier than that, okay? It all comes down to first taking your piecewise function and breaking it up into pieces. Then writing down what kind of graph are we dealing with, a linear, a quadratic, absolute value, what kind of graph is it? And then make sure you look at your constraints and get your table of values set up correctly, and then don't forget, sometimes there'll be a hole, sometimes there won't be. Understand that, okay? So, there we go. You graphed a piecewise function. It doesn't make sense. Your graph has 2 pieces to it, okay? That's the hardest part. I think we should do one more. Whether you agree or not, we're going to do one more to get some practice. So here it is. Let's go ahead and practice another one. You can work ahead or watch me. It's totally up to you. Okay? Alright, here we go. So my first piece is negative x squared plus 2. My other piece is, oh, by the way, earlier back here we evaluated a function at given values. I'm not practicing that again. I really feel like that was pretty easy. The graphing is the part I feel like we need more practice at, okay? So the second piece is g of x equals x plus 2. So there's my 2 pieces, okay? Now, let's write down everything we know. First of all, if you like to write it with a y, I have no problem with that. You don't have to, it's up to you. Notice that my highest power is 2, and that's the highest power I have, so I have a quadratic here. So when I graph it, it should be somewhat of a parabolic curve, okay? Over here, if you want to write it with the y, if that helps you, feel free to. the highest power I see of a variable is 1. So I have a linear graph, okay? And so if I have a linear equation, it's going to graph a line. Alright, now, we've written down our information. Now let's get a table of values set up. Now this one here, we're dealing with a quadratic, so I would strongly recommend you get a good 5 points in your table of values, okay? That's the smart thing to do. Now, notice we're gonna start with 1 because that's my number right here, okay? So go ahead and put a 1 right here. Then it says x values less than or equal, so we're gonna go less than. So less than, go down, go down, go down. There we go. Let's see what happens. Let's substitute 1 in to my equation right here, okay? So let me slide this over just a tad. There we go. And let's substitute 1 in for x. Now look, guys, the negative is not getting squared. The squared only goes to the 2. It's really like this. It's really negative 1 x squared. There's really a 1 there, even though you can't see it. Okay? Do you understand that? This 1, this negative sign right here, is not being squared. So you bring the negative sign down, then put your parentheses, then put your 1, and then square it. Okay? So 1 times 1 is 1, but there's a negative sign there. So negative 1, positive 2 is 1. Alright? Now let's substitute 0 in for x. So negative sign first, then parentheses. 0 squared is 0. Negative 0 plus 2 is 2. So now I'm going to put a 2 in for my y. Alright, now let's substitute negative 1 in for x. So I have my negative sign, bring it down, then parentheses, negative 1 squared, positive 2. Now be careful. When you square a negative 1, you get a positive 1. Okay? But there's a negative sign here. So negative positive makes the 1 negative positive 2. So you're going to get a 1. Alright, now let's substitute negative 2 in for x. Negative sign first, parentheses, then negative 2, then squared, and then positive 2. Well, now, yes, negative 2 squared, negative 2 times negative 2 is positive 4. But you have a negative sign outside here, so negative positive makes it a negative 4. Bring down your positive 2, and you get out a negative 2. And then last but not least, we're going to substitute negative 3 in for x. Bring down your negative sign, then parentheses, then negative 3, quantity squared, positive 2. Now, yes, a negative 3 squared and negative 3 times a negative 3 is a positive 9. That's true. But you've got a negative sign you got to bring down. So negative positive makes it negative 9, positive 2, which gives you a negative 7. Alright, so I'm going to go ahead and erase this and slide this back over. And there's my information for the first piece to my piecewise function. Now, let's take a look at this function here. It's a linear graph. It's a line. So really for a line, I only need 3 ordered pairs. That's pretty simple. And my constraint is x greater than 1. But remember, you always start with this first number, whether it's equal to or not. Always. Whatever this number is, you put it here. Whatever this number is, put it here. Now, am I allowed to put 1 in for x? No, I'm not. There's no equal sign here. The only thing I can put in for x is numbers greater than 1. However, I'm going to go ahead and do it and circle it and make a note to myself. There's going to be a hole here. And by the way, I'm just joking. Humor intended. There's going to be a hole here. Alright? So, now I want all values greater than 1. So 1, then 2, then 3. So, substitute 1 in for x, or 1 in for x. 1 plus 2 is 3. Substitute 2 in for x, 2 plus 2 is 4. Substitute 3 in for x, 3 plus 2 is 5. There we go, guys. Really not too difficult at all, okay? Now let's go ahead and pull this graph down to the next page like we did before. And I don't think we need to add any lines to this one, so we can make it as big as we want to, okay? So let's graph this first. 1, 1, and 0, 2. So there's 1, 1, and there's 0, 2, alright? And then we have negative start here and go this direction like that. Well, remember what I taught you. Always start at the first point. If you've set your table of values up the way I've taught you to, putting this number in first, then start at your first ordered pair, 1, 1. So start here and go toward the other points. So we have a little more than half a parabola, okay? So there we go, look at that. Now, let's go ahead and graph our line. My first ordered pair is 1, 3, and there's going to be a hole there in the graph, okay? So over 1, up 3, and put a hole there, alright? Then 2, 4, and 3, 5. So 2, 4, and 3, 5. Now, do we start here and go this way here? Well, remember, what is your first point? 1, 3. In your table of values, 1, 3. So we'll start at 1, 3, and go this direction. So these piecewise functions definitely have arrows, but they don't have arrows on the end of both. Like this one starts here. It does not continue on. On a test or a quiz, if you continued this on, you would lose points. This does not continue on this way. If you did that, you would lose points on a test or a quiz. Same with this. It continued on this way, arrow, but not this way. It continued this way, but not this way. That's why it's so important you learn to put your pencil on the first ordered pair. Okay? Guys, I hope this video has made sense and been a help to you. If you have any questions, don't hesitate to call or email.